All right, so no lab today. Awesome. Got a busy afternoon. You'll go out and enjoy this weather since we've all been cooped up for the past year, it seems, or at least most of this year. So we left off when we were talking about water use efficiency and some of the different types of irrigation that we can use. Some of the efficiencies with our conventional furrow versus a drip, things like that. Water use efficiency is going to be big in the future because we are not able to recharge our aquifers as fast as we were back in the day because of the changes in the rainfall patterns. Next, moving on to soil formation. This is a picture. If you go out I-40 and make a left onto 111, this is right behind that big ridge right there, the big mountain. I guess I consider it a mountain. But this has a good idea of the topography and kind of how the soil is formed over time. I am into drones, and so this is a really cool picture for me to take. So there are 5 soil formation factors. The first being the parent material. It has to come from somewhere, and that is going to determine kind of the different kind of soil that we might have, and also some of the physical properties in there. That parent material, the minerals that were in that rock that was formed, are going to determine some of our chemical properties. Climate is going to be one of them. How temperature and moisture influence our weathering rates. Some of the different organisms that are present during this formation that are going to either drag some soil or decompose some leaf litter, some material. Topography, as we've just seen in the picture before, whether it was on a slope, how is it in a valley, is it in the bottom, where did the soil form? That's going to influence the depth of our soils. And then finally, time. And then it just takes a long time for soil to form. It is a very slow process. We're talking hundreds and thousands of years in order to form and enter to a soil. So we begin with this rock. There is some rainfall that is going to wear away or erode this bedrock. It will begin to disintegrate. We can have heat. We can have in a cold where the water makes its way into a crack and freezes. That freezing, when the water freezes, it expands, kind of pushes that rock away a little bit. It breaks some, kind of like some people's pipes did over Snowbid. And then as that parent material begins to disintegrate, a bird might have eaten a berry somewhere and comes and deposits that berry in the bedrock, in that little soil, and begins to start a plant. That plant will begin to grow. The roots will now start to grow into the bedrock or that little bit of soil, and it will start to disintegrate that even more. The plant will grow, it will drop a leaf or two, or all of their leaves over a certain, over its life cycle. The microbes in that soil will begin to decompose the leaf litter, and then that will begin to add organic material and organic matter to the soil, and we will begin to develop horizons. Going all the way back to our crossword puzzle, the way this book currently is set up is not set up the way that the nature and property of soils is set up. So if you were taking 3000 level, I would have taught this first. But the way the book is set up, I wanted to follow that along. But that crossword puzzle, the soils around us, was a good introduction about but what we're really going to be studying is soil formation and then finally nutrient cycling. So soil forms from the bottom up. It is a layering process. We start at the bottom with our R horizon. The bedrock is disintegrated. Starts a C horizon. The accumulation of some materials will then move up to finally an O horizon, which is the top part of our soils. But eventually, over time, more material will fall on top of that O horizon, and the soils will become deeper. So along the face of that cliff that is right out there on 111 as you turn off of I-40, you can actually begin to see some of these processes and some of the additions and the soil forming. We see a few trees are making their way, kind of establishing. This is on the lower left picture. We can have zones of alluviation where it moved from an upper horizon into a lower horizon. We have some alluviation right there. But these trees are beginning to form, and you can see little bits of soil beginning to form right there on that ledge. More soil being formed right here where rocks are disintegrated, kind of broken up. Roots are making their way into that and kind of crushing that soil, breaking it apart. It's undergoing some weathering processes through freezing because it was really cold here the past couple days. The moisture that was in there forces that rock to break, and then it begins a weathering process. So there are, I think I had 6 or 7 different types of parent materials. We'll have residual, colluvial, and so the residual and the colluvial are typically from some sort of rock fragment. Our alluvial and marine sediments are going to be associated with some water fraction. Next, glacial till and wind transported materials. And finally, organic deposits. So going back to our soil formation that's happening right in our backyard, a residual is what's going to happen when that rock breaks up and forms right there in place. So it resides right where it broke. It has not been moved. It is right there, just in place. Next we have colluvial, which is at the bottom of a slope. And so those rocks break and then are moved down, whether it be they just fall off the face of the cliff and form on the road, or if we go back to the very first picture that we saw, the material that fell down into the valley, that is going to be our colluvial or collects. So residual is right where it resides. Colluvial collected at the bottom of the slope. Next, we have the alluvial parent material that is deposited by rivers or streams. And so if you remember, when we talked about Stokes' Law, you'll remember all the way back when I had the illustration of everything starting in Minnesota and all that soil being churned in the Mississippi River, and as it flowed down and eventually overflowed the banks, and then the soil settled out in sand first, followed by the silt, and then by the clay. And so that's where we have those alluvial deposits. That is the soil that was picked up from some other place, and then as a river or a stream overflowed its banks, that the soil settled out in sand, silt, and clay, shortest to furthest from the river or the stream bed. From Mississippi, being from Mississippi, the Mississippi Delta, although it is not technically a delta forms at the mouth of a river, but it is an alluvial floodplain. And so the sand and silt and clays that made its way down from Minnesota, overflow, and then kind of form the soils that are so productive in the Mississippi Delta. So on the top picture, just basically a riverbed or a stream that overflows its banks, and you can see the alluvium soil start to form. We have more soil that is deposited on top of it, and that is how our soil is built. As an alluvial fan, much like the formation of a delta, kind of like at the mouth of the Mississippi, as that soil enters a larger body of water, so we have this unstoppable force meets an immovable object, and we have all this material that is moving so fast, and then as it hits the larger body of water, let's say the Gulf of Mexico, it stops. And slowly but surely, all of the soil starts to settle out first as that water continues to move over. The soil will settle out and form an alluvial fan. Much the same way that happens in the Delta. Marine sediments, you probably won't deal too much with marine sediments, being in Tennessee. There are 4 different types, not that we would really need to know these, but it's good information to kind of have. I was really surprised that this cosmogenous derived from, I know, right? That's kind of derived from space. But that would be something like a meteorite that maybe landed in the desert that broke and formed soil. But yeah, derived from space. Not a whole lot of that going on. So for our lithogenous, when I think about that, I think about volcanoes and anything that might have been protruded from a volcano, some dust, some air that has those going all the way back to our rock cycle. Some of those materials that spew out of a volcano. Biogenous, being bio, so that is something that is living. You might see corals or shells, some sort of bone. Hydrogenous being some chemical precipitation, and then again our meteorites and space dust. Glacial till, materials deposited by ice, because glaciers, right? So anything that was kind of frozen in that glacier, that the ice melts, leaves that material there. Wind transported materials, you'll primarily hear this as loess, L-O-E-S-S. And so in the Delta, in the Mississippi Delta, at some point in time, the landscape turns into a hill. And that is where the loess winds picked those materials up and then deposited them on top of each other and formed those hillsides. And organic deposits are going to be peat materials, and so these are going to be some sort of plant material that was deposited over time. Some of you might be familiar with sphagnum moss in the nursery industry. Next, moving on to climate, the greatest impact on soil formation. We're going to need to have some sort of rainfall. There's going to need to be precipitation. Water is a great solvent, and so if you do not have water, you do not have any weathering processes. Next, followed by temperature, and then for each 10-degree Celsius increase, a biochemical reaction rate doubles. And then finally, we all like nice weather. So do plants and animals and insects. So that climate is going to influence the types of pests or the types of animals and insects that are around, that are walking by, breaking up the bedrock, that are depositing the plants, that are depositing those seeds, that are forming our soils. Look at some of those organisms. And then finally, topography. So again, back to our first picture, that you see the large cliff. That soil was broken away, deposited in the bottom of that valley, and then began to become a life source for trees and grasses and plants and animals as well. So on our slopes, on our high ground, you would not find much depth of soil because it's all colluvial. The only material that would be there would be the residual material. But most of it eventually, rain fell, eroded the soil, eroded the rock face, and that rock and parent material ended up at the bottom of the slope. And then it takes a long time for this soil to form. Over millions or hundreds and thousands of years, that eventually we have these rock fragments that are disintegrated, start to form some organic debris. Eventually a tree or a plant can make its way in there and begin to break some of that up, that undergo some of these weathering processes. We will have our organisms begin to make a habitat there because they're feeding on the plants. So we talked about the 5 factors being the parent material, the climate, the organisms, topography, and time. However, the processes are different. And we have additions and losses. And then we will have translocations and transformations. You also need that. So additions are going to be some sort of organic material, such as a leaf, is going to fall. The organisms will use that as a carbon source, some energy that will begin to decompose that. There might be some deposition, such as some other parent material that has some other minerals in it that is deposited and undergoes the weathering processes and changes a little bit of the makeup of that soil physical and chemical property. Fertilization. and not just human fertilization, but other kind of fertilization. From animals? Do animals fertilize soil? Yeah, they do, right? So that's where the organisms come into play. They are going to deposit some sort of excrement that contains nutrients that the microbes will use, that they will break down some sort of leaf material. My grandfather would rake up all of his leaves and put them in the garden and then go get horse manure so that they could break down, that the microbes in the horse manure could break down the leaves a little better. And that would be in addition to the garden that is going to influence that growth. And then finally, precipitation. And precipitation from two sort of, I don't want to say, so rainfall obviously, but also think about currently where we are with acid rain. And so that acid rainfall is going to be part of the chemical processes of breaking down or weathering our soil particles. There are going to be losses from leaching or erosion. Plant uptake. And then we talked about evapotranspiration. So it'll rain, but then the plants are going to use that water, which is going to influence the soil formation. For translocations, this is going back to the crossword puzzle. We have a zone of eluviation, and you can remember eluviation as exit. So when some material exits a zone or a layer, it is translocated into a layer below it, or possibly above it. We have illuviation, I, where material moves into a zone. And so these two processes are related, correct? Because we have one leaving and one entering. So from a zone of illuviation, more likely to be from above, and then illuviation moving into a zone below. Pedoturbation is going to be some movement of the soil or some mixing, most likely by our organisms. So this is part of the soil forming factors, but this is the process through which that soil is formed. So we have those organisms moving through the soil that are dragging or moving different fragments into different areas that are undergoing more weathering processes, breaking down, plant uptake, it may be more moist. So those are kind of important as well. Salinization. When I think of saline, I think of salt. And salts can be from some fertilization. And then finally, alkalization, being more specifically the accumulation of sodium. And this is going to be more likely in our more arid climates, such as deserts. Those weathering processes have not happened. There are not a lot of additions. And then finally, transformations. primarily going to be the weathering process, being exposed to different climatic conditions that are going to break or disintegrate or erode or change the composition of some mineral, one of our parent materials. Decomposition is going to be the breakdown of a mineral or some organic material like leaf litter. Humification being the continuous breakdown of that organic material into some humus. These are going to be our plant materials, sticks, trees, shrubs, bushes, possibly even animals that are decomposed completely down to where you cannot distinguish whether it was a plant or an animal. Mineralization, and we're going to talk about mineralization more later in the semester. And I'm going to go ahead and kind of set this up a little bit, that mineralization is organic to inorganic. Mineralization is organic to inorganic. And we'll talk about immobilization being the opposite, where it is inorganic being then used into organic. And this will come in when we talk about nutrient cycling, probably in the 4th module. And then finally, we synthesize some new compound throughout all of these processes, whether it be inorganic or organic. And so all of these processes together, where we have this parent material that undergoes this weathering process throughout the climate. We have organisms that make their home in that climate and those weathering and that parent material. Plants end up disintegrating that bedrock and form these layers. And so we have the 5 soil forming factors being climate, parent material, topography, organisms, and time. And then our 4 processes: additions and losses, translocations, and transformations. I want to do that pretty quick. I think we're done for the day. Everyone's like, yeah, good. All right, we will see y'all on Monday.